Okay, welcome to chapter 26 in the practices book. This is about running a data center, page 459. So it's really all about capacity planning. You know, how much power do you have? How much space do you have? How much cooling? How much network? It also includes things like life cycle replacements, adding and removing servers, and then, other things like maintaining your outside, communications connection, like your ISP. And then remote management. But basically, it's really capacity. That's really what it's about. So capacity management on page 459. So we're talking about physical space, right? I can't add a new server because I don't have enough room. Rack space. I can't add enough server because I don't have enough space on the rack. And then I can't add a server because I don't have enough power. I don't have enough cooling. Okay, those are the big things. So adding to capacity could be very expensive. Probably a capital expense involved. And so it kind of makes sense to build these things right the first time, because if you would say, well, I need to expand my server room, I'm gonna knock that wall out and move it over 12 feet. Wow, that's gonna be dang expensive. Oh wait, I need twice as much air conditioning. That's very expensive. Okay, so you guys got that. So let's talk about trends. Let's say you had a server that had I'm making these numbers up, that had 32 cores, and it took 600 watts to run. Again, I'm just making this up. But when the new one comes out, the newer chips are smaller and they're doesn't consume quite as much power, right? You've all heard that, right? But when it comes time for you to replace a server, you're not replacing it with an identical 32 core unit. You're replacing it with a 64 core unit, and so the power requirements come out about the same. I mean, you're getting more, don't get me wrong. But as far as, here's the thing, the plug going to the wall doesn't care, okay? That you made it high density and you increase the clock speed and you got more core count. It doesn't care about any of that. Power is power, okay? So when you start replacing units, you almost always are going to be upgrading and replacing the old, right? You're not buying the same thing over again. And so, yeah, you can get more processing power in a smaller space, yeah. But a new server is probably not going to drop your electric bill. I'm just saying. I mean, it could, but most of the time it doesn't. Okay, one of the things they talk about is an automatic inventory system. That's pretty doggone important. There's lots of talk about this in this chapter, but basically you need to have a list of all of the physical servers, all of the virtual servers, what they do, that kind of stuff. Models, serial numbers, date of install, all that. You need all that stuff. And for God's sake, don't attempt to do this by hand. I mean, you really do need an automated system that automatically keeps things up for you. So there's an example, one of those shaded area examples in the book on page 460, where they only had 9 racks in a colo facility. And they had a pretty slow replacement cycle, so things didn't change that much. So they said, well, look, let's just turn on the automatic, we don't actually need it, but let's go ahead and turn on the automatic discovery feature for our inventory. And they found out they had servers that haven't been used in years. They were still in the rack. They were still plugged in, consuming power and requiring cooling, but were doing nothing. Yeah, you need an automated system. You really need that. So there's a company out there, I kind of sort of mentioned before, that rents rack space. Okay, so what the heck is rack space? Well, there's a standard out there. It's called a 19-inch rack. And this is a particular one that has an acoustic cover over it. So a full rack, sometimes these guys are like 6 feet tall, and have places where you can plug in computers. This one has a door on it that kind of keeps the noise down. In a typical server room, that might be handy, but to tell you the truth, in a data center, I don't care about the noise. I would much rather have the employees wear hearing protection in that room than I would be to have a cover over it, okay? Just saying. All right. So you need to be, we talked about inventorying the existing servers in the racks. Well, to tell you the truth, you probably need to inventory the amount of empty space you have in a rack. Yes, you need to you need to inventory the empty spots. I am not kidding you guys. Okay, so there's a thing called a rack unit. it's kind of a thing. Anyway, a rack unit is like 1.75 for it's called a U1. So I go buy a U1 server, and it's, 1 3/4 inches tall, and it just slides into my 19. So I know how wide it is. I kind of can tell how deep it is. A U2 is 5 inches. A U4 is 7 inches. And so these things, when you look at these little holes right here, they kind of sort of look like they're evenly spaced, don't they? But if you zoom into this thing, or if you've ever used a 19-inch rack, they are not evenly spaced. See how this little piece right here is tighter than that one? Like, these are 0.625 a point, and this is a 0.5 difference. Wow. Okay. So yeah. In other words, to give it room for, like a gap between the two, the spacing on these things are different. It's kind of confusing. I have bolted up a 19-inch rack, putting it, put the top screws in, and I go, great, this is exactly where I want it. Let me go put the bottom screws in. Dang, I got it in the wrong hole. Pull it out, move it over, drop it down, and now the 2 screws fit. Okay, I'm just telling you it happens. Okay, so a U1 unit, a U2 server, a U3 server, a U4 server. Okay, you know what all that means. So should I place all of my stuff right on top of each other? I mean, right, no gaps or anything? Well, let's say I had a U2 server, and I might want to be replacing it next year. Maybe I ought to leave an entire U worth of space either above or below it, because the next server might be a U4 space or size. So leave some gaps, okay? It also helps for cooling and air circulation, but hey. Have a rack zone. In my world, we had a 19-inch rack, which was our DMZ. It contained the front end to our email, not the entire email system, but the front end to our email system, a DNS server, and a web server. And, well, it also had some other things in there, like a VPN endpoint. But those were the things that were exposed to the internet, okay? And we put them all in a separate rack. And, in fact, just for grins, we painted the rack red to let you know this is the dirty side of the system. All these racks over here with their native colors, typically black. And so we knew this was clean and this was dirty. And if you wanted to be really, really, really smart, I mean, I wish I could have done this years ago. I would separate those racks apart so that you couldn't, like, for example, accidentally plug a cable into this rack and then stretch it over and plug it into that one. If they were side by side, that's a real possibility. Like, hey, I need to be able to plug this in. Oh, I don't have any space. Let me bridge this from over here to over here. Man, you just blew security smithereens. So if you could, have the red rack separated from the rest of the rack. The DMZ could be physically separated in its own rack and further away from the other racks. That's just an idea. Okay. So, do I put similar units? Let's say I have a database and a backup database. Do I put them in the same rack? I wouldn't. I'd put them in a different rack, just in case something caught on fire, and got smoke damage, and you have to replace everything in the rack, that kind of stuff. Just saying. Okay. In data centers, there's the thing, it's the whole concept of a cold aisle and a hot aisle. Basically, they have the racks back to back. So cold air comes in, it goes through the rack, and then exhausts out the backside. If you have all the backsides lined up, of course, no human goes down the hot side. It's only a gap in there. And so, yeah, you kind of need to know about that if you're trying to install racks. Do you put them side by side, or do you put them back to back? It's kind of your choice. Okay. So power on page 462. So you need to track, the minimum, average, and maximum power. I've got one of these little doodads here that I use. Okay, this is just a little power meter. I mean, you just plug it in, the electrical socket, plug your thing in. How much is my toaster actually taking? Or how much is my computer actually taking? How much is my router actually taking? Now, some of them, if you have things plugged into a UPS, it could be that your UPS can tell you the number of amps it's pulling. Okay, that would be kind of cool. But outside of that, this is, an industrial version of this, would be something you probably need to have in your toolkit if you're going to be operating a data center. Because that you want to know, how much power is being used by each one of these things. Okay, kind of cool. So some sort of a power monitor. And it'd be kind of cool to kind of keep track of it. You know, like here, do it like once a year or something and see, whoa, something's going on here. This guy's using more power. Oh, yeah, we added an extra server, that kind of thing. So you need the total power when you're talking about ups and cooling, right? The power determines the cooling, right? All that electrical power is turned into heat. 100% of it is turned into heat. So the more power you have, if I've got 10,000 watts worth of power going to my room, I know exactly I need how many tons of air conditioning I need. There's a formula. Okay, so let's just talk about it a little bit more. So you need the size electrical service and the breakers. Hey, by the way, I'm switching topics to electrical engineering. Okay, so just bear with me for a minute. What's the purpose for the breaker in your house? Is it to protect your equipment? Is it to protect your toaster? Is that what it's for? No, it's to protect the wiring. If you put in a 30 amp wire to the toaster, you're trying to make sure that the wire doesn't melt and burn your house down. So the purpose for the breaker is to protect the wiring, okay? And so if you put in 30 amp wiring, you get 30 amp breaker. If you put in 60 amp wiring, you get 60 amp breaker. Okay, see how this works? Okay, good. All right, sorry. So how do you estimate the actual load? Well, okay, that's kind of tough. How do you plan for higher power densities? Because most likely the machines you're going to be replacing are going to be smaller and crammed in together. So, you know, there's even this whole thing called server consolidation, where you take, 3 servers and you combine them down to one. It takes about the same amount of power, but unfortunately you used to have 100 amps going over here and 100 amps going over here and 100 amps going over here. But when you combine them together, you have 300 amps going through one cord. Okay, so I need to have that kind of capacity planning. Okay, emergency generator. So do I size for everything in the room? Yeah. I mean, including the lights, everything. And air conditioning, which clearly the air conditioning system is not inside that room. So I need emergency generator big enough to handle the entire load of the data center, server room, whatever we're talking about, plus all of the air conditioning, okay, simultaneously, okay? And then if you have anything left over, emergency lights for the rest of the building, right? Okay. So don't make the emergency generator just for emergencies. Make it for, it needs to be sized for the entire load of the server room plus cooling. An uninterrupted power supply. So one of the questions you need to ask is, how long do I need? I mean, I can run off batteries for, 15 minutes, 30 minutes, an hour? What do I need? What's my requirement? Well, if you have an emergency generator, typically it takes about a minute for an emergency generator to come online, get up to speed, synchronize, and pop in. Okay? That's how long it basically takes. So technically, you could do an ups that will last, 15 minutes would be plenty of time for you to discover that the generator didn't fire and, go find out what's wrong, that kind of stuff. And then you need to actually measure the requirements over time. I mentioned that. Maybe your ups can do that for you. That would be kind of cool. If you buy a commercial ups, it has an application that actually, draw a chart for you. Here's it over the day, and here's over the years, and that kind of stuff. Having a power meter like this is a little complicated if your rack is connected to 3 different electrical cords going to the ups, right? You have to have plug this in one of them and then switch it over and do the math. I mean, come on. Okay, so running out of power on page 463. That's a shaded area story where basically they talked about, hey, we've reached our limit on power, and therefore we're going to institute a 2-for-1 swap. You're going to take 2 machines out before you can put one in, kind of a thing. And doing this little 2-for-1 swap, they were actually able to stay within their power budget without having to, have an electrician come in and install additional breakers and additional wiring and all the rest of that stuff. Okay, so we're coming up on the 15-minute mark, so you guys know how this works.